Welcome to qnawire.
For this problem on the topic of particle physics, we are given data for B and K whilst tuning a medical cyclotron for use in isotope production. B is the uniform magnetic field in the cyclotron, and K max is the maximum kinetic energy of the particle that is accelerated, which is a proton in this case. The radius of the proton path at maximum kinetic energy is r, and this has the same value for each magnetic field value. We want to first compare the kinetic energy values to the rest energy mc squared of a proton and discuss whether it is necessary to use relativistic expressions in our analysis. We then want to graph K max versus B squared and find R using this data. We want to know the maximum kinetic energy for a 0.25 Tesla magnetic field and the angular frequency of the proton when B is 0.4 Teslas. Now for part A, we know that the rest energy of a proton is 938 mega electron volts, and the kinetic energies in the data table in the problem are all around 1 mega electron volt or less, and so we can see that there is no need to use relativistic expressions. Now for part B, our graph is sketched as follows, with K in mega electron volts on the y-axis and B squared measured in Tesla squared on the x-axis. And we want to find R. Now the graph is clearly a straight line, and the slope of this graph is equal to 6.748 mega electron volts per Tesla squared, which is 1.081 times 10 to the minus 12 joules per Tesla squared. And the formula for the maximum energy, K max, is Q squared R squared over 2m times B squared. So a graph of K max versus B squared should be a straight line with slope Q squared R squared over 2m. And so we can solve for the slope R, or rather for the radius R, which is the square root of 2m times the slope of the graph divided by Q squared. Putting in our values, this is the square root of 2 times the mass of a proton, 1.673 times 10 to the minus 27 kg, multiplied by the slope, 1.081 times 10 to the minus 12 joules per square Tesla, divided by the charge of the proton, 1.602 times 10 to the minus 19 coulombs squared. This gives the radius of the orbit to be 0.375 meters, which is 37.5 centimeters. Now for part C, using the result from our graph, we get the maximum kinetic energy equal to the slope times B squared. And so we have the slope 6.748 mega electron volts per square Tesla, and we are given the field to be 0.25 Teslas, and that's squared. This gives us an energy of 0.42 mega electron volts. Lastly, for part D, the angular speed omega is equal to the magnitude of the charge Q times the magnetic field B divided by the mass m. And so this is 1.602 times 10 to the minus 19 coulombs times the magnetic field 0.4 Teslas divided by the mass of the proton 1.67 times 10 to the minus 27 kg. This is an angular speed of 3.8 times 10 to the power 7 radians per second.